Arithmetic 4. Arithmetic 4 includes indices, estimation, significant figures, and standard form. So in indices, the first law states that when you have same bases, but both the values have different powers, for example, a power x and a power y, and they both are being multiplied, you will add the power. So a to the power x times a to the power y is going to give you a to the power x plus y. For example, 2 to the power 3 times 2 to the power 2. Same basis, different index. That becomes 2 to the power 3 plus 2 to the power 5. The second law states that when you divide two values with the same base but different indices, you're going to subtract the indices. So it's a to the power x minus y. For example, you have 2 to the power 3 divided by 2 to the power 2. You'll get 2 to the power 3 minus 2, which is 2 to the power 1, or it can simply be written as 2. The third law states that when you have a to the power x and you're multiplying the whole thing with y, it becomes axy. For example, you have 2 squared that is commonly multiplying by the 2. You're going to multiply the two powers to get 4. And law 4, 5, and 6 we did at the start. Law 4 states that anything to the power of 0 is 1. Law 5 states that anything to the power -1 takes in the denominator. And law 6 is such that when you have different bases, but they both have the same power, you take the power common. For example, if you have x power a times x power a times z power a, same indices, different bases, that becomes xz whole to the power a. Okay, now let's try out some questions. So pause it and try to solve it. The answer for this should come out as 2 upon x to the power 7 upon 2. For this, the answer should come out as 2 times x to the power 7 upon 2. For this, the answer should come out as x to the power 3 upon 2 upon 5. For this, the answer should come out as 2 times x to the power 7 upon 2. For this, how are we going to do this? We have 32 to the power x is equals to 2, and we want the value of x. This is an equation. We're first going to convert 32 to a value in terms of 2. So how can I express 32 with base 2? 32 is 2 to the power 4. So we can write 32 to the power x as 2 to the power 4x. When we have 2 to the power 4x is equals to 2, how does that look like? 2 to the power 4x is equals to 2, and the power here is 1. Since the bases are same, can I equate these two powers? I can. So 4x becomes 1, and x comes out to be 1 upon 4. In estimation, what do you have to do? Simply, if you have 4.99 and you have to estimate it around the top to the first decimal place, you're going to have a look at the first decimal place. You're going to look at the number to the right. Is that number greater than or equals to 5? Yes, it is. So we're going to add 1 to the value we're looking at. So 9 plus 1 becomes 10. And in 10, the 1 is carried over to the 4. So it becomes 5.00, since any numbers to the right of the value we're looking at get canceled. Significant figures. We have questions and we have to express them all in significant figures. So if I have 1.23 and I want to express it in two significant figures means numbers that are not 0. But the 0 will be counted if it's, for example, 1003, so that has 4 significant figures. But if it's 130, it just has 2 significant figures. Or if it's 1.230, so it just has 3 significant figures. If I want 2 significant figures here, I can round it off in a manner. I can round this last number off so that I just have 2 significant figures, and I'm going to get 1.20. That just has 2 significant figures. Then I have 0.0123. Over here, how many significant figures do I have? 3. I just need 2. So again, I'll round off the 3 to 0, and so I have 0.0120, or just 0.0012. This is 0.012. And then I have 123. And I want to round it off to two significant figures. Once again, I can round off the 3 to 0. How can I round off the 3 to 0? Because 3 is less than 5. So if rounding it off to the unit is giving me something that is to two significant figures, I'll do that. So that becomes 120. And if I want to express a value in standard form, I have 0.001, and I want to express this in standard form. Remember, when you move the decimal to the right, it makes the power of into 10 negative and to the left positive. So if I want to make it in standard form means that there is just one value to the left of the decimal place. This is standard form because there's just one value to the left of the decimal place. And if I move the decimal place, I have to add this into 10 sign. So if I move it here to have my decimal place over here in the manner that it will become 1.0, so only one value to the left of the decimal place, I moved it 3 times to the right, and to the right it makes the power of 10 negative. So 3 times to the right and the power negative, that becomes into 10 power negative 3. That becomes 1.0 into 10 power negative 3. Then I have 342 and then 4 zeros, which is actually 3.42 million. And I want to express it in standard form, so my decimal should be here, so that I have only one value to the left of the decimal, and the decimal right now is here. So moving it 1, 2, 3, 4, 5, 6 times to the left. And since moving it to the left gives us a positive value, a positive power for 10, it's 10 to the power positive 6. Now I'm going to express that 3.42 into 10 power positive 6. This is not into 106, it's 10 to the power 6. Thank you for watching our video. Subscribe, like, and share. The next video up is on set language and notation for GCSE and IGCSE O-level maths. Don't forget to check out our Instagram at c.sgetdegrees101.